Okay, so welcome back. Today we're going to start part 2 in our series where we help you to understand some very basic concepts surrounding multi-threading, tasks, asynchronous, await concepts in C# Visual Studio Windows Forms applications. And we talked in the first part about the basic concepts. We drew some analogies to try and help you to understand it. And honestly, it's a topic that can get kind of confusing. One of the reasons is there have been multiple variations of the same asynchronous multi-threading concepts in C# Visual Studio Windows Forms application over the years. So we're going to look at a very simple way that I tend to do asynchronous or simultaneous tasks in my software. And ultimately, we're going to develop this very simple application you see here. And it's basically just got a couple buttons and a text box. And also, we've got this numeric up-down control. And what it's going to do is going to allow us to specify how many tasks we want to run asynchronously or in parallel or simultaneously. And it's going to show us how long it takes to run those tasks. In the code, we're going to see a very simple implementation I use to set up asynchronous tasks. So here I've got one task set, and I'm going to hit start. And in our previous video, we introduced the concepts that I use of like having a supervisor in a factory that is providing tasks to a bunch of automated robots. And that's kind of the analogy we're using in this series. So here we've got some feedback. We've got one task. We launched the supervisor, and the supervisor told a robot to do the task, and then it returned, and the robot went off and did the task. And later on, the robot task is completed, and it gave us a result of whatever this number is, and it took 11 seconds. And in this code, we're going to have this task, which is basically a method, and we go out and we build this huge matrix of numbers and we fill it, and that's the task, and it's going to take about 10 or 11 seconds to do that task for the robot. And then what we can do is we can say, okay, I want to do that 5 times simultaneously, so I can crank this up to 5. Now I've got 5 robots working on similar tasks at the same time, and I can start this, and it launches the supervisor, and the supervisor tells the 5 robots to go do the tasks. And now the supervisor can go do other stuff while the robots are off doing their tasks. And then after 15 seconds, we've got these 5 answers from the 5 robots. And you can see it took a little bit longer to do the 5, and we'll talk about that. That's basically what our application is going to do. And we're also going to look in Windows Task Manager. You go down to the taskbar, right click, and choose Task Manager. And we're going to see the cores in my CPU. I've got, as you can see here, a 8-core processor with 16 logical processors. You can see here. And you can see there's not a lot going on as I'm doing this recording. And what we can do is we can watch the CPU response. In this case, we're going to do 5 processes asynchronously in parallel, and we can watch the CPU response. So I'm going to hit start, and you can see here in the top left, we've got one core that is going up to very high values. We've got another one over here. We've got, if you count them, we've got 1, 2, 3, 4, 5. So it's using 5 cores, and after 15 seconds got the answer, and you can see the cores now drop down to almost 0. So this is an indication that we have used 5 cores of our CPU simultaneously to do these 5 processes. So let's take a look at the code and see how we implement this. So here we are in C# Visual Studio Windows Forms application, and we've got a very simple form, and all I've done is drag and dropped a text box, which you see here, and a couple of buttons. And I've added one control here called a numeric up-down control that allows you to select how many simultaneous asynchronous tasks or processes we're going to run. And we just showed 5 simultaneously. And what I've done is I have set this up-down numeric control with a minimum of 1 and a maximum of 16. And with 16 on my particular CPU, it will use all 16 logical processors. So you select this and you can go down to maximum and minimum. I've got 1 for a minimum and 16 for a maximum. And that's about it. And then we can grab that value whenever we need it. So to generate the event handlers for the start button and the exit button, just double click. And here is the simple code for this application. And as I usually do, I've got some regions here. I've got a to-do region, and I've got the methods. I've only got 2 methods and 2 event handlers for each of the buttons. So really a very simple application. We'll start out, we're going to use system_collections.generic. That's so we can keep a list of all the tasks. As we talked about in the first video, the supervisor's got a list. He's keeping track of the tasks given to the robots. So we're going to have a system_collections.generic. System diagnostics, that's going to allow us to use a stopwatch to figure out how long each set of tasks is going to take. And then, of course, system.threading.tasks, so we can use the asynchronous tasks. So the first thing we're going to do is define our list of tasks. Again, that's like a supervisor's notebook listing all the tasks that he is assigning to the robots. And so we've got a list of tasks that are type double. When we do tasks in C# Visual Studio Windows Forms, these are tasks that will return values that are doubled. So it's like any method with a return value. However, when we're dealing with tasks, it's going to return a task of type double, not just a double. And we'll talk about that in a bit. So we've got a list of tasks of doubles, and we're saying that's a new list of tasks of type double. And then we have to define our stopwatch, which we're going to call stopwatch, so we can figure out how long this is all taking. So that's all we have to do with the initial parameters. We've got our Windows form. The event handlers are very simple. Button exit, we're just going to do an application exit. Button start is we're going to first give some feedback to the user in our text box. And the only thing that this button start does other than that is call a method called supervisor async. And that's basically going to start the supervisor we talked about. And it's an asynchronous method, which means that he's going to launch things simultaneously. We'll talk about that. So the first thing, our text box, we're going to, as we hit the start button, we're launching the supervisor. Then we are calling the method, the supervisor async method, which is the supervisor, where he's going to launch the tasks and tell the robots to do their work. And then once it has done that, it's going to come back to this text box and says return from launching the supervisor. So as we said, when we call the supervisor, it's going to go into the supervisor method, it's going to launch the tasks and then come back here, and the tasks are going to be off doing their thing. So that's the only event handlers. So now we have the supervisor async, which is basically the supervisor method. And it is going to launch this task method. For each robot, it's going to launch one task, and it's going to feed it a number and say, work on this task using this input number. And that is going to return a double, as we said before. So the tasks are going to be of type double. And our supervisor async method that's going to launch all the tasks is we're adding an async to it that's defining it as it's going to be setting up some asynchronous or parallel methods. So when we hit the start button, it runs this asynchronous method. And the first thing we're going to do is we're going to restart the stopwatch so that we can time this. And then we're going to run a bunch of tasks. And we're going to use this line of code, and we're going to do it depending on what is selected in this numeric up-down control. This is going to tell it how many times we want to start a task. So from I equals 0, I less than numeric up-down value, whatever the user has selected, it's going to run that many tasks. And it's going to use tasks.add. So we're adding another task to this list of tasks. And we're going to use this very important line which says task.run. And the task that's going to run is this robot task method, which we have down here, and it's going to feed it a number, and the number is going to be used in this method, and it's going to take this number, it's going to work on a very big array of numbers, like 1 million numbers, and that's going to cause it to take some time. And it's basically going to take this I, which is going to go up to the number of specified by the user. It's going to feed that as a number that it can work on. But basically it's going to go through and start as many tasks using this line that the user has requested and add that to the list of tasks. And later on, we can use this list of tasks to determine if all of these tasks are done, then we can move on to the next step. So here we're running all the tasks, and then we're giving some feedback that says, okay, the supervisor method, which is this method, has successfully launched the async robot tasks. So at this point, these tasks are often running in separate threads, and then we're going to use this await. Now, this method is an async method, which means that you're going to be awaiting some tasks that are going to be generated in this method. So when we have this async, we have this await, and we're going to use this systemthreading.tasks class that says, okay, we've added all these tasks to our list of tasks. We're going to await until all of them are done. And when they're all done, we're going to assign the results to this double array, which is called final. And it's going to have all of the doubles. Again, these are returning doubles. It's going to store all of the results. If we have 5 tasks running, there's going to be 5 values that are returned by this method, and they're going to be assigned inside this array of doubles called final. So final will have 5 doubles in it. It'll be an array of 5 doubles that contain the answers for when all of these tasks are completed. At that point, we're going to stop the stopwatch and give some feedback to the user. We're going to say the async robot tasks have completed. Here's the results. And the elapsed time is going to be the stopwatch elapsed milliseconds divided by 1,000. And that's how many seconds it's going to take. And then we're going to step through all of the elements of this final array for each var result in final. And we're going to print out the answer. So it's result.toString. And when that's done, I'm going to do a tasks.clear to clear all of the tasks, so that we run this again, they will start from 0. So now the only other remaining code is this individual task method for each robot. And we're feeding it a number, we're feeding it an integer, and it's returning a double. You can make this whatever you want. All I did is I defined an array of doubles, and I gave it 9 million elements, 9 million doubles, and I called it a big array. And what it's going to do is it's going to fill each of those 9 million elements with a double value, a random double value, and that's going to take like 10 seconds or 15 seconds to do it, to do all 9 million elements. So I've got a var big array is a new double with 9 million elements. Total values, what it's doing is filling all those array elements and then keeping a running total of all of the sum of all the array values. And in this total values, we're starting out with 0. So I'm defining a long integer, I equals 0, I less than the big array.length, which is 9 million elements. And it's going to generate a new random number each of the 9 million times. And it's going to assign a value, which is mult, which is the number you're feeding in an integer, times random next double. So it's getting a next random number, multiplying it times whatever you feed it, and filling in the big array element value to that number. And then it's keeping a running total vals plus equals big array I. So at the end, we're going to come out with the total values, which is the sum of all the 9 million elements. And again, this is going to take like 10 or 15 seconds. But if we do it asynchronously, it's going to take less. And it's going to return the total values, which is the sum of all the elements. You can put whatever you want in here, but this is just one way to do a lot of work that takes time so we can see what the response is. So that's about it for the code. Now, you might think that For example, if I do one task, I do this once, we saw that it takes about 10 seconds on one of my cores. So you might think if I'm doing, for example, 16 simultaneously on all 16 cores, the total time it would take to do all of those is only still 10 seconds because presumably they're all running simultaneously. Well, that's not actually true. There's some overhead and some optimizations you can do. One reason why this is a nice application is you can play around with things like that. You can run this and you can adjust the number of tasks, simultaneous tasks, and see how long they take. I have done that for all 16 cores. I've done from 1 to 16 tasks and plotted the results in this Excel spreadsheet. And we saw that if I do one task, it takes 10 seconds. But if I do two tasks, it takes 12 seconds, not 10 seconds. So what we're saying here is if I do it asynchronously with separate cores, here's the time it takes. If I do it synchronously, it should take the sum of the time. So for example, if I do it once, it should take 10 seconds. If I do it synchronously, one after the other, it should, of course, for two tasks, it should take twice that. And if I do it again, it should take 30 seconds, then 40 seconds, so on. But if I do it asynchronously, which is in parallel, the actual times are not all 10 seconds. They take more time with the more threads. So there is some overhead there. So down here in blue is the asynchronous time. And while you think it might be flat no matter how many tasks you do, it actually increases. So maybe in the future we'll look at how to improve that or optimize that, but just keep in mind that just because you're doing them asynchronously doesn't mean they're going to be the same time no matter how many tasks. And again, we're doing this on our cores on our CPU. We've done other videos talking about how you can do it much, much faster on your GPU using thousands of cores. So I encourage you to look at that. But that's about it for this video. If you like any of these videos, I encourage you to hit the like button, subscribe, hit the bell notifications. But most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.